Hi everyone, I am Bhavarno and today we will continue our discussion on the chapter of force that we have started in our last video. So, in the last video we have discussed about the basics of force and moment of force that is also known as torque. So, if we remember, we have already discussed about force and torque. So, can you remember the formula for force? That was F is equal to ma, mass into acceleration, and the unit was Newton. And the formula for torque was force into perpendicular distance between the line of action of force and the axis of rotation or the pivot point. And the unit for torque was Newton meter. Okay, we all are clear with this. Now, moving on to the next topic, our today's topic of discussion is couple and moment of couple. So, if we want to visualize couple, let's take the example of the bottle. Okay, let's suppose I am trying to open the cap of the bottle. So, in this way, I'll open it. And what is the direction of rotation of the cap? This is anti-clockwise. That means I am putting a force in the cap in the anti-clockwise direction. Now, let's observe the phenomena closely. I am using my these two fingers. Okay, and I am imparting a force to the cap in the anti-clockwise direction. That means with this finger I am giving a force in the upward direction, that is causing it to move in the anti-clockwise direction, and with this thumb I am applying the force in the downward direction. In simple words, I am trying to twist it. That means I am giving one force in the upward direction and one force in the opposite direction, and I am trying to make it a twist. Now, when I am giving this, the direction of the two forces are opposite, and when two forces are acting together to make something happen, we are calling it a pair of forces. So, two forces are acting simultaneously in the cap so that it gets opened. So, in simple words, we can say couple, I mean, in any rotating motion, a single force applied on a pivoted body. Okay, when we apply a single force on a pivoted body, it alone does not cause rotation. There is always a pair of force acting on the body that makes it rotating. Now, actually, this rotation is always produced by a pair. If we write this, uh, what was I'm talking about? The opening of the cap. Let's take the example of the opening of the cap. I am using two fingers and I am giving two forces in the opposite direction. So, uh, let's describe it as a single force. For the rotation of a body, always a pair of forces are present that are acting in opposite direction. Okay, if we want to describe it visually, so if we want to understand it visually, we can use this diagram as reference. Let's say we are opening a tap. We have all seen, and also we have also used a water tap, all of us. Let's say this is the tap. Okay. Now, whenever we want to open or close it, we use force. We use our two fingers and we tend to rotate it. Now, when we give a force in this direction, simultaneously we apply a force in this side in this direction, that is opposite to the previous force. We say this is F1 and this is F2. These two forces are acting in a pair in this body to make it rotate, and this is the axis of rotation. Okay, if we see in the top view, we will get to see this. See this as this is the pivot point, and we are acting. The forces are acting in this way. So these two forces that are acting in the body to make it rotate is known as a couple of force. Now, some examples of couple are when we turning of a tap, opening the cap of a bottle, etc. We use these forces in our daily life. Couples are acting everywhere where there is a rotational motion. Okay. Now we have already seen that whenever we are applying a force in a body which is at some distance from its pivot point, it is uh, it is trying to rotate the body, and we are saying this as the pivot point around which it will rotate. So for these kind of forces we are calculating moment or torque. So for this arrangement of force there will be two moments acting, because this is also acting in the similar fashion to the previous one. Now for these couples we introduce moment of couple. Now put the topic of discussion as moment of couple. Let's say this is the body and two forces are acting in this way, and the axis of rotation is this. Okay, this is F1, this is F2, or let's say both the forces are F. Just the directions are opposite, and this is the axis of rotation. Now in this case, if we depict this as point A and this as B, we can find out the moments for both the points. For point A, the moment will be F into, let's say this distance is D, F into D, and similarly there will be a moment for the point B, and this will be, and at point B the moment will be F into the perpendicular distance, let's say the perpendicular distance between these is E, and the total distance between the application line of these two forces be A. Now tau B is equal to F into E, and if we want to calculate the total force, that is the total turning moment which is helping the whole body to turn, will be we will just add these two torques, and our total will be F into D plus F into E, or we can simplify it as taking F common, D plus E. Now what is D plus E? This was A. Now F into A is the final result. This is the total torque which is acting on the body to make it rotate. Now from this we can so we got the total moment of the pair of forces, that is the couple. So we can write the empirical formula as, or the generalized formula as, moment of couple is equal to either force into distance between the, or perpendicular distance between the two forces in action. Okay, so this is the derived formula for moment of a couple. So I hope you have understood why we need the moment of couple, because these forces are acting to a point which is apart from the pivot point. It is not acting in the point of the pivot. So we need the moment of couple. Now moving on to the next topic. Okay, so talking about the SI unit of moment of couple, this is going to remain same. F into, let's say, A, or the distance, F is equal to Newton, and A will be in meters. So this is going to be the SI unit of moment of a couple. Now moving into the next topic, that is equilibrium of bodies. You pause first. Now the next topic of discussion is equilibrium. Okay, so what do you mean by equilibrium? Let's suppose this is a body resting on a table, and we are applying two forces in the body in the opposite direction. And let's say this is case 1. Now this is case 2. Again the same scenario. Body is resting and there is some application of force, let's say in different directions. Okay, F1, F2, F3, F4, F5, and F1, F2. Here the condition is, first condition is F1 greater than F2, and second condition is F1 is equal to F2. Now can you answer me, what is the effect that is that the body is going to show in this case when the F1 is greater than F2 and when the F1 is equal to F2. This is easily visual. This can easily be observed from the figure that in this case the body will move to its right. This would be the direction of motion of the body, and in this case the body will not move. It will be at rest. So, what is the observation that you can make from these two conditions? When I am saying that the F1 is greater than F2, the body is moving. And when I am saying that both the forces are equal in magnitude and are being applied in the opposite directions, then it is at rest. So that means when the forces gets balanced by each other, then the effect of the force also gets cancelled and the body remains at rest or does not show any response to the application of the force. So this is the case, and this is what we call it as equilibrium. Same here, every force that is acting at at an angle of say theta. Here every force is acting at some angle. So the force will have two components. That is, one is horizontal component and the other would be vertical component. So if we consider all the horizontal components of the force that is acting in the body from the right side and the horizontal components of the force that is acting on the body from the left side, we will see that the forces gets cancelled. Forces from right is equal to forces from left. Both gets cancelled and the resultant force acting on the body becomes zero. This means that the forces gets balanced. No effect of force in the body at rest. As simple as that. And this is the concept of equilibrium. No external force, when no external forces, no effect of external forces are being shown by the body, we call it in equilibrium. Now if we define this, uh, if the number of forces are acting on a body and the effects of the forces gets cancelled out, and the body shows no response to it, then we call the body that it has attained equilibrium. So when multiple forces are acting on a body and each of the effects of forces are being cancelled by one another or being balanced by one another, then the body shows no response to it. and the body is being called as in equilibrium. Now, equilibrium, if we classify equilibrium, equilibrium can be of two types. One is static equilibrium and the other one being dynamic equilibrium. So, what do you mean by static equilibrium? You all know the meaning of the word static, that means it is at rest, not in a moving state. So, in this case, what happens is that if we apply multiple forces on the body and in result it retains the state of its rest, then we call it that the body has attained the static equilibrium. Okay, so the body was initially at rest in time t0 when there was no force acting. The body was at rest, and at time, let's say t is equal to 5 seconds after the application of force, the body is still at rest. We have applied two forces in its opposite direction and the forces gets balanced by each other. So the body is still at rest. It is not showing any motion. That means the body is in static equilibrium because its ultimate state is at rest. When the body in the state from rest, even after even after being influenced by several forces, we call the body that we call the body has attained static equilibrium. Let's say this is a body and several forces are acting, but still the body is at rest. That means these forces gets cancelled. Then we call it at static equilibrium. Now there is another part, the dynamic equilibrium. So dynamic is the state of motion of the body. Okay, so let's say initially a body was at rest, was moving with some velocity, let's say v, and again we have applied several forces. Okay, and we have observed that even after applying several forces on the body continues to move in the same direction with the same velocity v without showing any effect or any response to the forces being applied. Then we call it as dynamic equilibrium. The body is showing dynamic equilibrium in this case. If the forces are not balanced, then the body would have increased its velocity or have decreased its velocity or would have changed its direction of motion. So the body has shown no response to the application of the forces. So we call it as dynamic equilibrium. If we define this, When a body still shows its initial state of motion, and is moving with some velocity v, if it does not change its state even after getting influenced by several forces, then we call the body to be in dynamic equilibrium. Okay, if you want to visualize this with a diagram, let's say this is a car moving with velocity v, and we are applying multiple forces in multiple directions, and as a result we have seen that there is no change in the state of the car, or there is no change in the velocity of the car. That means that all these forces gets cancelled or gets balanced out. So the car is maintaining its original state, that is in motion with the velocity of v and at a certain direction. So we will call this car that it has attained the dynamic equilibrium. I hope it is clear to you all the concept of equilibrium and the classification, that is one static and the another one being dynamic equilibrium. Also, if we want to look into some real life examples, I hope you people have ever visited the market and have seen beam balance. This is common. So the beam balance also works on the equilibrium. Okay, works on the concept of equilibrium. Let's say this is the beam balance. So we put the weight here, and we put the stuff that we are going to consume here. Now, when the beam gets balanced and shows no rotation, the beam is fixed to this point and is free to rotate. When the beam shows no rotation at all, we call it that the beam has attained the equilibrium position, and what it actually tells is that the torque in this direction and the torque in this direction being applied on the beam gets equal, gets cancelled out. So this gets balanced, and hence there is no rotation at all. So this is the main working principle behind the beam balance. If we want to analyze this with the moment of force, let's say this point is at, this is the midpoint of the beam. Okay, so this distance and this distance is equal, and the force, let's say we put a force F1 and force F2 in this direction. So this torque becomes F1 into L, and torque 2 become F2 into L. So as the length, the perpendicular distance is always equal, when the forces will get equal, the torque will also get equal. So this is the main concept behind the beam balance. When the weight of the body we put here is equal to the weight of the body we put here, then there will be no rotation at all, and the beam will be in equilibrium position. This is one common real life example you will ever get to see. Uh, and then there is a topic in your syllabus, the principle of verification of the principle of moment. Let's say, okay, the topic of discussion is of verification of what is the topic? Verification of principle of moments. So let's say we want to verify if it is true or if it works correctly or not. Let's say we have taken a steel rule, 30 centimeter steel rule we have taken, and this is the midpoint, 15 centimeter. We have hanged it with this point as the hinge or hinge point or pivot point. We have hanged it here. Now we want to verify if the principle of moments holds good to this. Let's say this is the scale, and let's say we have two weights, W1 being 10 kg, suppose, and W2 being 20 kgs. Okay, so now you hang one of the weight here, let's say W1 and W2 here. Now keep taking the readings, and you will find that when the how will calculate the force. This is the distance. Let's say this distance is 5 and this distance is 15. This is W1 and this is W2. Now what will be the torque in this side? Let's say T1 or tau 1. Tau 1 will be 5 into 10 is equal to 50, and tau 2 will be 15 into 20, 150. That means it is not balanced. Now put this weight here. Okay, put this weight here. This will be tau 2 will be 10 into 15, 150, and tau 1 will be 5 into 20, 100. Still tau 1 is lesser than tau 2. That means we have to change the d of this side so that we can balance both these sides. Now if you want to get the distance where we will hang it to make it static, we put the formula as tau 1 is equal to 150 is equal to d into 20. Then we get d as 150 by 20. D will be 7.5. Okay, so d will be 7.5 centimeters from this point. Okay, so there is a mistake. We can't take the units in kg and centimeter together. Then the tau 1 and 2 will not come in SI units. We will have to change the units first to the SI units, that is in meter, and this is okay, this is in kg, and then we have to solve. This is just for your experimentation or observation. That's why I have just given a rough idea to you all. And I hope you have noticed that in this condition, if we put the weight, second weight in a distance at a distance of 7.5 centimeter from the pivot point, the the scale will get balanced, and this shows that the principle of moments is verified. So this is all about the couple, moments, and the equilibrium of forces. Hope you have liked the lecture. Meet you in the next session. Thank you.